So what is the what we have learned in the last class? Actually, that is a different shape of crystals. I'm discussing the different shape of crystals. Okay. So, do you have any query regarding crystalline properties? Do you have any query regarding crystalline properties? Viraj, Viraj, am I audible to you? Am I audible to all?
Sir.
So, do you have any query regarding crystalline properties? What are the shapes I have discussed already? What is the effect of crystalline structure in the formulation studies? No confusion. If you don't have any confusion, we can start the next one. Right? So, next come with the polymorphism. Do you have any idea regarding polymorphism? What does it mean? So it is the ability of the compound to crystallize as more than one distinct crystalline species with different internal lattice. Internal lattice means, see, these are the forms of lattice. That is cubic, tetragonal, triclinic, rhombic, hexagonal, monoclinic, and trigonal. So these are the different lattice. Okay, they have same crystalline properties. They have same properties, but they have different internal structure or internal lattice. So different crystalline forms are called polymorphs. Okay. So different crystalline forms are called polymorphs, and they have different shapes, but they have the same chemical properties. They have different internal lattice. They have different crystalline shapes, and they have different physical properties also. But their chemical properties should be same. Okay. So it is called the polymorphs. What about the apomorphs? Do you have any idea about apomorphs? Apomorphism and polymorphism. Ambika, do you have any idea regarding apomorphs and polymorphs? Do you have any idea of apomorphs and polymorphs? Ambika, Ambika, am I audible to you?
Satyam network problem চলি আছে।
Okay. So, তাই শুনি পোৱা নাই নেকি ভালকে?
ভালকে শুনা নাপাই স্যার।
So, Zakir Hussain, can you say me what is apomorphs and polymorphs? So, polymorph I have discussed. That means polymorph have different chemical shapes and structures. Okay, they have different that means physical properties, but they have also they have different physical properties, but their chemical properties become same. These are called the polymorphs. What do you mean by apomorphism? Zakir Hussain, what do you mean by apomorphism? Any idea?
So, distinct one crystalline form with lattice.
Hmm. One crystalline form, but they have different chemical properties. Their structure is same, but they have different chemical properties. Their properties are different, but they have similar. Their structures are similar, but their properties are different. Here, what their properties are same, but their structures are different. Sorry, their
Structure is same.
structures are different, but their properties are same. In polymorphism, their structures are different, but their properties are same. But in apomorphs, their structures are same, but their properties are
Different.
different. Okay. So polymorphisms are two types. That is anisotropic and monotropic. Okay. So these are the two types of polymorphs. The polymorph which can be changed from one form to another by varying temperature and pressure is called anisotropic polymorph. That means if one polymorph can change their what? Their properties by varying temperature and pressure. If pressure and temperature change, then it will change their properties, then it is called anisotropic polymorph. Example is sulfur. One polymorph which is unstable at temperature and pressure is called monotropic polymorph. Okay. If we change temperature and pressure, if we change their properties, then it is called anisotropic. And if in all temperature, that is that polymorph is unstable, they can change their properties. It is called monotropic. Example is glycerin. That is glycerin state. Okay. So polymorphs differ from each other with respect to their physical properties also. By their physical properties, what are the physical properties? They may be different. That is solubility, melting point, density, hardness, okay, compression characteristics, etc. So what are the first difference? That is two types of polymers. We can derive two types of polymers with the help of their pressure and temperature. If in every temperature and pressure if it changes, it is unstable, then it is called monotropic. And if we change the pressure and temperature, it will vary their chemical or physical properties, then it is called anisotropic. Okay. So other properties also, that is solubility, melting point, density, hardness, compression characteristics is also a factor for the physical properties, that is different. One polymer is different from each other. Okay. So chloramphenicol. Example, chloramphenicol have three polymers, that is A, B, and C. Okay. So if B is more stable form, then we are preferred in the form of B. That means understood, chloramphenicol have three forms. First one is A, B, and C. Okay. But in comparison both of three, if B is more stable, then we prefer B. Getting my point? So this is about the polymorphism. So do you have any confusion regarding polymorphism? What is
A,
polymorphism?
B and sir, A, B and C মানে solubility, melting point, hardness নেই স্যার।
নহয়, chloramphenicol তিনটা পলিমার থাকিব পাৰে। chloramphenicol তিনটা পলিমার থাকিব পাৰে মানে they have different shape and size.
Yes.
Okay. Chloramphenicol different shape or size থাকিব পাৰে। Crystalline properties like chloramphenicol, example this one, cubic, tetragonal, and tricubic. If chloramphenicol also have cubic shape, that is one polymer. If chloramphenicol have tetragonal, then it is also one polymer. If chloramphenicol have tricubic, then it is also another polymer. If we consider cubic is a, tetragonal is a B, and tricubic is a C, then what happens if tetragonal is more stable than cubic and tricubic, then we can prefer tetragonal. Understood?
Yes, sir.
Okay, that is about polymorphs. Then, what are the analytical methods for to identify the crystalline properties of any molecules? Okay, but, by which method we can identify which are which have the which chemical have the which crystalline property? That is with the help
Clear one
of
আছে voice to clear one আছে
বাকিবিলাকে শুনিছানে ভালকে?
অলপ ভাঙা ভাঙা আহি আছে।
Clearly নাই শুনা স্যার।
Okay, I will try to speak loudly. Okay, my network connection is, I think it's good. So I will try to speak loudly. Okay. So see, what are the, that means chemical, sorry, what are the analytical techniques that we can derive their crystalline properties? Okay. So first one is the microscopy. With the help of microscopy, we can see the structure of the particular chemical structure of the particular substance, whether it is crystalline or amorphous. If it is crystalline, then what about the polymorphism they have? Okay, it is apomorphism or it is polymorphism. What they have, we can identify. Fine. With the help of microscope. With the help of compound microscope, we can go with the that means to identify whether it is crystalline or amorphous. Another one is the hot space microscopy. In hot space microscopy is an advanced technique of microscopy. With the help of hot space microscopy, we can go for the identification of that means crystalline properties. Then thermal analysis. We have heard about the thermal analysis. What are the thermal analysis we are using to identify the polymorphs or crystalline properties? Do you know about the thermal analysis techniques? Anyone? Anyone know about the thermal analysis techniques? What are the thermal analysis in case of compatibility or in case of crystalline properties?
Study of temperature.
Hmm?
Study of temperature.
How? How can you go for a study of temperature?
So by changing its temperature, we can study this
How?
analysis.
What is the analytical technique? What is the analytical? এটা কোৱা কি আছিলে analytical technique? Thermal analysis. Thermal analysis কি কি আছে?
হৈছো স্যার।
Hmm?
পাহৰিছো স্যার। মন
কেনেকে? অম্বিকা, Selim, Selim, can you say what are the thermal analysis techniques? So see, what thermal analysis is, can you do you heard about BSc analysis, FTIR analysis, differential scaling calorimetry? No. Yes or no? So with the help of BSc study, we can go for the BSc and FTIR study. We can go for the thermal analysis. Okay. Then X-ray diffraction. Okay, X-ray diffraction study we can identify the characteristics of their crystalline properties. Then infrared spectroscopy, that is IR spectroscopy. Then photon magnetic resonance, that is PMR spectroscopy. Then NMR, nuclear magnetic resonance spectroscopy. And another one is the scanning electron microscopy. Have you heard about scanning electron microscopy? Yes or no?
So,
No. So okay, so microscopy. With the help of microscopy, how can you determine the that is behavior of that is crystalline behavior of the one substance? Okay, that is material with more than one refractive index are anisotropic and appear bright with brilliant colors in black polarized background. Okay, okay. So those who have refractive index that is more than one, they have the high tendency to absorb the light and it will reflect with the brilliant colors in the black background. Okay. intensity, we can check the intensity of the color. Okay, so color intensity is dependent on the crystalline thickness. Okay, if the thickness of the color, if the thickness is more, the thickness is higher, then the color intensity should become less. If thickness is lower, then color intensity will be more bright. So isotropic materials have single refractive index, and these substances do not transmit light with cross-polarized filter and appearance light. If we pass the light through isotropic material, then it does not reflect any. It does not have it has single refractive index, and it does not transmit light through that particular substance. And the back, that means background, that is those polarized background become totally black. Okay, in case of isotropic. So this is anisotropic and isotropic. We can determine which one is the isotropic and which one is the anisotropic. If in case of anisotropic material, it will show the colors in the that is background, and in isotropic material, it does not show any color because the refractive index is it have the single refractive index, so it does not show any color of the background. Okay, by this microscopy, we can conclude which one is the anisotropic and which one is the isotropic. So, what are the advantages? So, by this method, we can study the crystalline morphology and difference between polymorphic forms. Polymorphic forms is isotropic or anisotropic. So, what is the disadvantage? This require as well as trained optical crystallographer. So, it required trained optical crystallographer. We cannot go with this that means equipment because it requires trained optical crystallographer, as there are many possible crystal habits and their appearance in different ways. So orientation is the important. In which orientation the color forms, they can with their particular behavior, we can conclude that which they have what type of crystalline properties. Okay. So it is in case of microscopy, it is all about the color. If color is formed in the background, that means it is anisotropic. If color does not form, then it is called isotropic. Okay. So next is hot stage microscopy. Okay. The polarizing microscope fitted with hot stage is useful for investigation of polymorphism and melting point and transition temperature. Okay. So if we add that means hot plate in polarized microscope, then it is called a hot stage microscope. So it is very useful to identify the polymorphism, melting point and transition temperature. Okay. So this is here you can see that is a picture of when after that means we are putting the sample in hot stage microscopy. This type of pictures you can see. Okay, and this is the that means what are the structure of the hot stage microscopy. You can see the various parts of the hot stage microscopy. Okay, so what are the disadvantages of this hot stage microscopy? So in this process, when we are applying the temperature, if the molecule have the temperature sensitive, then it will become liquid. Okay. If it is temperature sensitive, then it will become liquid. So this is the main disadvantage of the hot stage microscope. Okay. So those who have the temperature sensitive method, we cannot use hot stage microscopy in case of temperature sensitive materials. Now come to thermal analysis. So thermal analysis mainly DSC and DT. Okay. So what is DSC? That is differential scanning calorimetry and differential thermal analysis. That is called DTA. Okay, it is mainly used for the investigation of polymorphism. So it measures the heat loss or heat gain resulting from physical or chemical changes. So when we are that means when we are measuring the heat loss or heat gain of the particular particular substance, okay, then it will change some chemicals or physical properties of that particular substance. When we apply heat, it will changes some changes will occur in the uh, particular that means substances, and we got their differences with the help of endothermic and exothermic peaks. The recorder is already attached with the DSC apparatus when we are just that means keep the sample and we are done for it for that means 15 to 20 minutes. It will show some peaks, that means endothermic peaks and exothermic peaks. By this process, we can that means understand their properties of their thermal behavior of their that means particular substance. For characterizing crystalline forms, the heat of fusion can be obtained from the area under DSC curve of melting area. That is called DSC curve. DSC curve means we can work some endothermic or exothermic. So similarly, heat of transition from one polymer to another may be calculated. With the help of DSC thermogram, we can calculate the that means transition heat of transition curve. We can at least calculate the heat of transition curve of particular polymer. A sharp symmetric melting endotherm can indicate the relative purity of the water. Okay, if in particular wavelength it will show some peaks, that is the standard peak. Okay, if in particular if the endothermic peak is not come under the limit, that we can calculate some chemical imbalance. The particular have some chemical interactions with it. If it will come under the endothermic peak, it will come under the range. The endothermic peak, if the endothermic peak is come under the range, then we can calculate it. It does not have any other interactions. That means if some asymmetric peak is observed, then we can calculate that it has some impurities. Okay. So DSC profile, I think DSC profile you have understood. So in case of thermal analysis DSC profile, if you have question, I can at least uh, make you better understand. Do you have any questions regarding DSC profile? How it is work? How can we got the atomic and exothermic peak, and with that type of atomic peaks, how can you understand that if we have some impurities or not? Do you have any confusion? Yeah. Do you have any confusion? Ikram, Zakir Hussain,
Yes, sir.
do you have any confusion regarding DSC apparatus or how can we according to DSC?
Sir, বুজি
Sir?
পোৱা নাই কি কৈছে?
DSC apparatus আমি কেনেকে ইউজ কৰোঁ তাৰ ইয়াৰ কেনেদৰে এনেকৈ আমি গম পাবলৈ ইয়াত ইম্পৰ্টেঞ্চ আছে নে কনফিউজন আছে?
Sir, your voice is not clear, sir.
Do you have any that means query about DSC apparatus, thermal analysis?
Thermal analysis.
Do you have any query? Do you have any query regarding thermal analysis? Ikram? বুজি পাইছে নে নাই? বুজি যদি নাই পোৱা,
স্যার ডিএসসি আৰু ডিআই টো এবাৰ কৈ দিব নি স্যাৰ?
DSC and DTA.
ডিএসসি আৰু ডিআই ডিটিএ
DTA.
বস্তুটো কিহত ইউজ হয় তোমালোকে বুজি পাইছানে?
এনালাইসিছৰ ইউজাৰ
কিহত ইউজ হয় বস্তুটো বুজি পাইছানে?
You can, sir.
নাই পোৱা। So DSC to এনেকুৱা এটা বস্তু এটা analytical tool, এটা instrument তাত আমি কি শিকিব পাৰোঁ their thermal behavior. With the help of thermal behavior কোনোবা এটা molecular কোনোবা এটা substance thermal behavior analyze কৰি পেলাই আমি গম পাম যে তাত purity কিমান আছে thermal বস্তুটো particular substance to purity কিমান আছে particular substance to crystalline behavior আমি গম পাম polymorphism আছে নে apomorphism আছে সেইটো আমি গম পাম ঠিক আছে কিবা impurities আছে নেকি সেইটো গম পাম কেনেকৈ গম পাম প্ৰথমতে আমি চেম্পলটো কি কৰিম আমি থাৰ্মেল প্লেটত DSC
ভইচটো অহা নাই
শুনা পাইছা
স্যার পাইছো
DSC apparatus first আমি চেম্পলটো দিম ইয়াৰ পিছত আমি চেম্পলটো ৰান কৰাৰ লগে লগে তাৰ কি হ'ব হিট প্ৰডিউচ হ'ব হিট প্ৰডিউচ হৈ যোৱাৰ লগে লগে হিটটো পাছ কৰিবলৈ ধৰিব পাৰ্টিকুলাৰ মলিকুলাৰ আছে পাৰ্টিকুলাৰ মলিকুলাৰ আছে যেতিয়া হিটটো ট্ৰান্সফৰ্ম হ'ব তেতিয়া কি হ'ব বস্তুটো ইয়াৰ যিটো বিহেভিয়াৰ আছে কিছুমান হেৰি তাত ৰেছপন্স দেখুৱাব ঠিক আছে সেই ৰেছপন্সটো কি হিচাপত পাম আমি এণ্ডোথাৰ্ম হিচাপত পাম এণ্ডোথাৰ্মিক গ্ৰাফ এণ্ডোথাৰ্মিক পিক ঠিক আছে ওকে এণ্ডোথাৰ্মিক পিক হিচাপত পাম সেই এণ্ডোথাৰ্মিক পিকটো যদি আণ্ডাৰ দ্য ৰেঞ্জ তাৰ এটা পাৰ্টিকুলাৰ ভেলিডেটেড ৰেঞ্জ ধৰা 20 to 50 কথা যদি আমি ডিএসসি ষ্টাডি কৰাৰ পিছত পাৰ্টিকুলাৰ সাবষ্টেন্সটো ডিএসসি ষ্টাডি কৰাৰ পিছত এণ্ডোথাৰ্মিক পিকটো যদি এণ্ডোথাৰ্মিক মানে ওপৰৰ পৰা তললৈ এনেকৈ যায় ঠিক আছে ওপৰৰ পৰা তললৈ যোৱা পিকটো যদি আমি চাওঁ যে ইট ইজ comes under the limit then we can conclude that it does not have any impurities on it. It does not have any other chemical reactions on it. Okay? যদিহে এণ্ডোথাৰ্মিক পিকটো লিমিটত নাথাকে is not comes under the limit, then we can conclude that it have some chemical interactions. Is it clear? বুজি পাইছানে
স্যার পাইছো
So next come with the X-ray diffraction. So what is the X-ray diffraction? So working principle, when beam of non-homogeneous X-ray is allowed to pass through crystals, X-ray beam is diffracted and is recorded by means of photography. Okay, X-ray করা দেখিছা? X-ray করা দেখিছা নে X-ray মানুহৰ বডিত X-ray কৰা
স্যার দেখিছো
X-ray কৰিলে কি হয় মানুহৰ ভিতৰত যিখিনি বল আছে beam of light to কি হয় এখন দি পাস হৈ যোৱাৰ লগে লগে এখন যিখন আউটাৰ প্লেট আছে সেই ফটোগ্ৰাফিক প্লেট বুলি কয় সেই প্লেটত কি হয় ৰেকৰ্ড হৈ যায় ঠিক তো সেম কথা ক্রিস্টাল এটা যদি মাজত পিকচাৰ পিকচাৰটো
Sir, I can't hear anything, sir.
wait have you checked your network is it okay
Sir, network बहुत problem है, sir.
here my network is okay right but you have to check your network properly
আপোনাৰ হেডফোনৰ যে মাইক্ৰফোনটো স্যাৰ ওচৰত ল'লে স্যাৰ শুনা পোৱা যায়
হেডফোনটো মাইক্ৰফোনটো ওচৰত নিলে শুনা পোৱা
হয় স্যাৰ
এতিয়া শুনা পাইছা এতিয়া ওচৰতে নিছো শুনা পাইছা
কি কয় স্যাৰ
এতিয়াতো ওচৰতে নিছো তুমি শুনা পাইছা
এতিয়া শুনা পাইছো স্যাৰ
মাজে মাজে ফ্লাকচুয়েটিং করে
So next come with the X-ray diffraction. Okay, X-ray kora dekhisa. So this check this particular diagram. Okay, what we have done, the crystal, that particular crystal of a substance is plot on this particular area. Okay, a beam of non-homogeneous X-ray is passed through it. Okay, this is the. Have you seen this one? It is area detector. Here we have placed one photographic plate. Here we have placed one photographic plate. We just pass the non-homogeneous X-ray through the crystal. When it will pass through the crystal, it will choose the properties of the crystal in that particular photographic plane. Okay, in this particular photographic plane, it will show the behavior of the crystals. Understood? শুনা পাইছা নে? শুনা পাইছা? Is it audible to you?
Yes, sir. Yes, sir.
Okay. So diffraction is due to the crystal which acts as a three-dimensional diffraction getting towards the X-ray. So we have to place the crystal here at place, then we have to pass the non-homogeneous X-ray on it, and in the photographic plate we record the behavior of the particular crystal. This is very simple. You just see the diagram. With the diagram you can understand what is the function of this X-ray diffraction spectroscopy. Okay. So random orientation of crystal lattice in the powder causes the X-ray to scatter the reproducible pattern of the peak that is intensities. Okay. So if the orientation is random, then crystalline lattice in the powder causes X-ray to scatter in the reproducible pattern. It will scatter, the light will be scattered, the light of beam of light will be scattered. Okay. The diffraction pattern is characteristics of the specific crystalline lattice of the given color. So how it will diffract? The diffraction pattern depends on the crystalline lattice of the particular substance. I have already discussed how many types of there are 7 types of crystalline lattice. So what type of the diffraction pattern depends on the structure of the particular. Okay. So in case of amorphous form, if it is amorphous, it does not produce any pattern. In case of crystalline behavior only, it will show some patterns. Okay. So single crystal X-ray provide the most complete information about the solids. So it will produce the beam of lights, it will scatter the lights, and it will produce the particular, that means show the particular behavior of the crystals. It depends on the crystalline lattice of the particular structure of the crystalline lattice. And in case of amorphous form, it does not form any, that means scattered beam of light. Okay, it does not produce any pattern. But in case of crystalline form, it shows some pattern on the background of the particular photographic plane. Okay. So this is about the X-ray diffraction spectroscopy. So I am just discussing about some analytical tools for which we can identify the crystalline behavior of some that means drug substance. In any substance, we can identify the crystalline behavior. Okay. So this is about the crystallinity. Do you have any confusion regarding the crystalline behavior? You can ask me the questions. If you have any confusion, regarding crystalline behavior? Are you understood or not? If you are not understood, then it is useless. What I am giving you, it is useless. If you little bit understood, that means you are under some profit. If you don't understand anything, that means it is completely useless. I am just wasting my time and your time. So try to learn something that what I am saying. If you are not getting my point, then you ask me the questions. Sir, why it is coming? Why it is happening? Why I don't understand these things? You can ask me, okay? Right?
স্যাৰ এনে পাৱাৰ পইণ্টৰ স্যাৰ এইখিনি বুজি পাইছো স্যাৰ, কিন্তু আপুনি যিখিনি কৈ আছে স্যাৰ এইখিনি অলপ ভাঙি আছে কাৰণে স্যাৰ প্ৰব্লেম হৈ আছে।
মই কোৱা কথাখিনি বুজি পোৱা নাই, মই কোৱা পেটাৰ্ণটো বুজি পোৱা নাই নে কি হৈছে? মই কথাখিনি শুনিলে বুজি
স্যাৰ
পোৱা
আপুনি যিখিনি কৈ আছে মানে সেইখিনি অলপ ভাঙি আহি আছে, চ' অলপ বুজি পোৱাত টান হৈছে স্যাৰ।
নেটৱৰ্ক ইছ্যু কাৰণে হৈছে। এনে মই কথাখিনি কওঁতে তোমালোকে বুজি পাইছা, যদি শুনা পাইছা
এনে স্যাৰ মানে ফ্লাকচুৱেটিং হয়।
বুজি পাইছো স্যাৰ, মানে ভইচটো মাজে মাজে হেৰি হৈ যায় স্যাৰ, নাইকিয়া হৈ যায়। বাকী এনে বুজি পাইছো স্যাৰ।
ঠিক আছে, কিবা কনফিউজন থাকিলে সুধিবা। কিবা যদি
স্যাৰ এবাৰ হেৰিটো দিব নেকি স্যাৰ, এই PDF টো দিব নেকি স্যাৰ?
দিম, মই যদি পঢ়ুৱাই লওঁ, ঠিক আছে।
স্যাৰ আপুনি জাষ্ট এই ভিডিঅ' কেইটা দিলেই হ'ল স্যাৰ পৰ্টেলত, আমি স্যাৰ সেইকেইটা চাই পেলাই যদি কিবা যদি কনফিউজন থাকে যদি আপোনাক সুধিব পাৰিম।
ঠিক আছে।
নহ'লে ছাৰ PDF টো দিলেও হ'ব ছাৰ। আৰু আপোনাৰ পঢ়ি মেলি যিটো বুজি নাপাওঁ ছাৰ আপোনাক এটা সুধিব পাৰিম।
ঠিক আছে, তথাপি মই ক্লাছটো কৰিবই লাগিব। ক্লাছটো তোমালোকক ল'বই লাগিব, ক্লাছটো থাকিলেহে তোমালোকে ডিৰেক্টলি তোমালোকৰ লগত কমিউনিকেশ্যন হ'ব। মই তোমালোকক
হয় ছাৰ,
দুটা কথা সুধিব পাৰিম, তুমি মোক দুটা কথা সুধিব পাৰিবা, তেতিয়াহে বস্তুটো বুজি পাবা।
হয় ছাৰ, হয় ছাৰ।
ঠিক আছে। Okay, I will try. I will just upload. I think 2-3 classes I have already uploaded. Okay? So I will upload it. Upload other like these classes also. Okay? You just follow the classes. If you have confusion,
Yes, sir.
you can take that.
Yes,
So, okay, fine. So next class I will discuss hygroscopy. Right?
yes sir.
Okay, sir.
Okay. So you just give all are present.
Yes, sir.
All are present. Imran Hussain, Ikram, Zakir Hussain, Salim, Hiraj.
Yes sir.
Sir, attendance to do, sir.
Okay, ठीक है. Salim Ahmed. Where is Amrita? Okay, ठीक है. उनके attendance तो दीजिए. reply करोगे लिखना. ইমরান বুজি পাইছা নে কিবা অলপ অলপ বুজি পাইছা নে ইমরান কিবা বুজি পাইছা নে অলপ
স্যার
কেৱল তোমাৰ মাতটো শুনা নাই ইমরান কোৱা
স্যার মই ক'লো অলপ অলপ বুজি পাইছো, অলপ কনফিউজন আছে, এইটো সুধি ল'ম বাৰু।
ঠিক আছে কিবা কনফিউজন থাকিলে লগালগ
পিছলৈ মানে কিবা অলপ প্ৰব্লেম আছিল, নেটৱৰ্ক প্ৰব্লেম আছিলে আৰু মাতটো অলপ ভাঙি ভাঙি আহি আছিলে আপোনাৰ।
ঠিক আছে কিবা প্ৰব্লেম থাকিলে সুধিবা মোক ঠিক আছে
নিশ্চয় স্যার, নিশ্চয়।
ক্লাছটো কৰিব লাগে কাৰণে কৰিম বুলি নহয় বা কিবা অকমান যদি শিকিব পাৰি চিন্তা কৰিম ঠিক আছে Okay then thank you students
Thank you.
so next
Bye.
class I will start
Thank you sir.
Okay.